This is the pre-calculus chapters 9 and 10 test review. Graph each point on the polar grid. So we need to graph the point of pi over 3 and negative 1. We're going to go to pi over 3, which is this line right here, and it extends through to the other side. And we're going to go negative 1 units. So instead of going towards pi over 3, we're going to go away from pi over 3, one circle out. So this would be point R. Now to graph point S, we're going to go 3 and negative 150 degrees. First, we can figure out what the positive corresponding value would be. So if I do negative 150 plus 360 degrees, this would give me 210 degrees. Now, you can figure out that this is 15, 30. We can keep doing that. This is 180. If we add 15, this will give us 195. Add another 15, this would give us 210 degrees. Or you could have converted the 210 degrees to radians. So I can multiply this by 180 over pi. We can reduce this. So this will give us 21 because 10 goes into both of these. 3 goes into both of these. 3 goes into 21 7 times. 3 goes into 18 6 times. So this is 7 pi over 6. So either you can write out all the degrees. Each one of these is worth 15 degrees. Or you can convert it to radians and find the same location. And we are going to go a positive 3 in that direction. So we're going towards the 210 degrees to the third ring, and this would be point S. Find 3 additional pairs of polar coordinates that are given between negative 360 and positive 360 degrees. So to do this, you can either add or subtract 360. If we add 360, that'll give us more than 360 degrees, so we will subtract 360 instead. So our first point can be 3 and negative 225 degrees. Our other options are if we make the R value negative, we can add or subtract 180 degrees. So we have 135. If I add 180, this will give me negative 3 and positive 315 degrees. If we make it negative, we could also take 135 and subtract 180, which would give us negative 3 and negative 45 degrees. And if you plotted all of these points and the original point, all of them would be coterminal points. We need to find the distance between the pair of points. Remember, to find the distance in polar, we're going to do r1 squared plus r2 squared minus 2 times r1 times r2 times the cosine of alpha 2 minus alpha 1. So this is our r1 and our theta 1, r2, and theta 2. So we're going to do 1 squared plus negative 5 squared minus 2 times 1 times negative 5 times the cosine of 7 pi over 6 minus a negative pi over 4. Now you can't put all of that into your calculator at once. Because our angles are in radians, you would need to make sure that your calculator is in radians, and you should get a distance of 4.84. Find the rectangular coordinates for the point given in polar form. So to find the rectangular form, we're going to do r times the cosine of theta and r times the sine of theta. So we can do 4 times the cosine of 210 degrees, and we can do 4 times the sine of 210 degrees. If you put that in your calculator, again, because these are in degrees, your calculator will need to be in degrees, and we will get negative 3.46 and negative 2 as the coordinates in rectangular form. Find two pairs of polar coordinates for the points given in rectangular form. So given this is in rectangular form, this is our x and our y. To find the r value, you're going to do the square root of x squared plus y squared. And to find theta, you're going to do the tangent inverse of y over x. You also need to remember if the x value is negative, you will need to add either pi if you're in radians or 180 degrees if you are in degrees. If the x value is positive, you don't have to worry about that. So to find our r value, we are going to do 2 squared plus negative 3 squared. And if we simplify that, it'll give us a radical 13. If we do the tangent inverse of negative 3 over 2, then our theta value is negative 56.3 degrees. So our ordered pair can be 13 and negative 56.3 degrees, but it tells us to find two ordered pairs. So again, remember, you can add or subtract 360 if you leave the r value alone. And the other point that we could get would be radical 13 and 303.7 degrees. Write the equation in polar form. So to write this in polar form, remember x is equal to r cosine of theta, and y is equal to the r sine of theta. Now, if you look at this first part, we do a binomial because we have a piece minus another piece. So we will have to write this twice and FOIL. For the second one, we just have two terms that are multiplied by each other, so we're not going to have to FOIL. We can just distribute that squared. So this is just r squared sine squared of theta. Over here, if we FOIL, so first would be r squared cosine squared of theta. Outside will be negative 2r cosine of theta. Inside will be negative 2r cosine of theta. And last, negative 2 times negative 2 gives us a positive 4. And then we still have all the rest of the part of our equation. Now, if we combine like terms and we rearrange this, I can have r squared cosine squared of theta. I am going to rearrange this. I'm going to put the squared pieces together. Negative 2 and negative 2 gives me a negative 4r cosine of theta. And I'm going to take this negative 2 to the positive 2 to the other side. Right now it's positive, so to move it, we're going to subtract it. And 4 minus 4 gives us 0. Now, to write an equation in polar form, we do want to keep have our equation be r equals something. So I'm going to keep everything that's squared on one side, and I'm going to take everything that is not squared on the other side. Now, if you notice, both of these pieces on the left side of the equation have an r squared. So I'm going to factor that out, and that's going to leave me with cosine squared plus sine squared. Now, if you remember back to your Pythagorean identities, sine squared plus cosine squared, or cosine squared plus sine squared, is just equal to 1. And we can rewrite this as r squared is just r times r. When you write an equation in polar form, you just want it to be r equals, so we can divide both sides by r to get rid of one of those r's. So we'll be left with r is equal to 4 cosine of theta, because we canceled those r's and we canceled these r's. So we need to write this polar equation in rectangular form. Now, we do know that r squared is equal to x squared plus y squared, and we know that r times cosine of theta is equal to x. If you notice, we are missing an r on both of these, which would make everything much easier. So we can multiply both sides by r to start with. As long as you do it to both sides, you're okay. R times r gives us r squared, and r times 16 cosine can be 16r cosine of theta. Now, like I previously stated, r squared in rectangular form is just equal to x squared plus y squared. And r times cosine in rectangular form is just equal to x. So if we rearrange this, I can write this as x squared. If I bring the 16 over, it'd be minus 16x. I'm going to leave a space. Now we are going to have to complete the square. So to find the c value, remember we do b over 2 squared. The b value is whatever is right in front of your x. So negative 16 over 2 squared is going to equal negative 8 squared, or 64. So we're going to add and subtract 64. Now I'm going to take this negative 64 to the other side because we don't actually need it. And so we will just be left with plus y squared. Because it's negative, we're going to add it, and it'll be 64 on the other side. Now we did that completing the square, so we could factor this side. Remember, whatever's inside the squared piece here will be inside the square piece here. So our equation, which will actually be an equation of a circle for this one, would be x minus 8 squared plus y squared is equal to 64. We need to determine the eccentricity, the type of conic, and write an equation for the directrix of this polar equation. So the first thing we need to do is we need to rearrange this equation. These equations are in the form of 1 plus or minus e times the sign in the denominator. So first, I'm just going to rearrange this. Now, we want the first term to be 1. So I am going to, in the denominator, factor out a negative 0.25. Negative 0.25 divided by negative 0.25 gives me 1. And this is a plus sign, or we can think of this as a plus 1 sign. So if we do 1 divided by a negative 0.25, that's going to give us a negative 4 sine of theta. Now we're going to simplify this. If we do negative 0.25 goes into itself once, negative 0.25 goes into negative 8, 32 times. So our equation is going to be 32 over 1 minus 4 sine of theta. So that means the original is in this form with a directrix. Because this is sine, we know it's a y, and because it's 1 minus e sine, we know it's going to be equal to a negative d. So the value that is in front of sine is your eccentricity. It doesn't matter what that sign is, that's just going to tell us about the directrix. So we do know our eccentricity is going to be 4. Since the eccentricity is greater than 1, we do know it's going to be a hyperbola. And we know that the numerator is equal to e times d. If the e value is 4, then d is equal to 8. And we know our directrix will be y is equal to negative d. Write a polar equation and directrix for a conic with the given information. So we know that the eccentricity is 6, and we know the directrix is y equals negative 7. So because this is y, we do know our equation is going to have sine. So it's going to be e times d over 1 plus or minus, we don't know which it's going to be yet, e sine of theta. And again, we know it's sine because it's y. Because our directrix is negative, we do know it's going to be 1 minus this value. Now, this tells me my value for d. We already have our value for e. So we're going to do 6 times 7 over 1 minus 6 times the sine of theta. Or our equation will just be 42 over 1 minus 6 sine of theta. Write the polar equation in rectangular form. So we're going to have to identify the eccentricity first and then determine what type of conic this will be. So remember, the eccentricity is going to be whatever is right in front of your sine or cosine. So our eccentricity is 1.25. Because it's greater than 1, we do know that it's going to be a hyperbola. Now, if you graph this equation in polar form, so you will need to be in polar, you'll need to be degrees, you'll probably have to change your window, you will see on your calculator that the vertices will be at 0 and 2 and 0 and 18. So that means the center of our hyperbola will be at 0 plus 0 over 2 and 2 plus 18 over 2, which means our center will be at 0 and 10, and this will be your h and your k. Now, because this is sine goes with the y, so our equation for our conic will be y first we know our h and our k. We need to find the a and the b. Now, a is the distance between the vertices. So if we look at the vertices, the x values are staying the same, so those really aren't going to affect us, but we need to find the distance between the two y values. So we know the distance between the vertices is equal to 2a. So we can do the larger minus the smaller, or 2a is equal to 16, which means a is equal to 8. We also know that the eccentricity is equal to c over a. We know our eccentricity is 1.25. The value for c is unknown, but we know our a value is 8. So to get c by itself, we can multiply both sides by 8, and we will get our value for c is equal to 10. Now, we do have two different equations, one for an ellipse, one for a hyperbola, but to find the b value when we're dealing with a hyperbola, c squared is equal to a squared plus b squared. Remember, for an ellipse, it's going to be c squared is equal to a squared minus b squared. But we can do 10 squared is equal to 8 squared plus b squared, or 100 is equal to 64 plus b squared. If we take that 64 to the other side, we'll have 36, or b is equal to 6. So now we have all the pieces that we need. We're going to do y minus k squared over a squared minus x minus h squared all over b squared is equal to 1. Now let's jump to the chapter 10 material when we talked about sequences and series. So for this one, we need to find the next 4 terms in the sequence. So if we notice, there's nothing that we can add that's going to make these large of jumps, so we're probably multiplying by something. So to see what that value is, we can take the second term, divide it by the first term, and we'll see that this is a negative 1/3. Now let's check to make sure that still continues. So if I do my third term and divide it by my second term, again, you're multiplying by negative 1/3. And fourth divided by third, again, is a negative 1/3. So each time we're just multiplying by a negative 1/3. So if we do 81 times negative 1/3, or 81 divided by negative 3, that's going to give us a negative 27. Negative 27 divided by negative 3 gives us a positive 9. 9 divided by negative 3 gives us a negative 3. And negative 3 divided by negative 3 gives us a 1. So the next 4 terms in the sequence will be negative 27, 9, negative 3, and 1. For this one, we need to determine whether the sequence is convergent or divergent. Remember, to do that, you're going to need to make a table, and you're going to see what happens to these values. Now you can go, because this is an explicit formula, you can put this explicit formula into your calculator. And then after it's in the y equals, you can go to your table by hitting second graph, and you can see what those values are. So for 1, we have 6, 2, we're at 14. And we could continue going on with this if we needed to, but it is pretty clear to see at this point that these numbers are just continually getting larger and larger and larger. So they are not converging onto one specific value, so that means they are divergent. Find the sum indicated in the sigma notation. Remember, you can put these directly into your calculator. If you wanted, you could do these by hand by plugging in n is 8. So we could do a sub 8, a sub 9, a sub 10, all the way up to a sub 13, and then just add those values together. Or you can put this directly into your calculator. To do that, you would hit the math button. You would go until you find summation. We're going to do x is equal to 8 until it's 13. And our equation will be 4x minus 10. Whatever variable you put underneath is just the same variable you're going to put into your equation. And if you hit enter, you should get 192. You would get the exact same answer if you did this by hand and you found each individual term. So this would be 4 times 8 minus 10, or 32 minus 10, which is 22. And you would do that for all these terms and add them together. Write an explicit and a recursive formula to find the nth term of the arithmetic sequence. So if you notice, you are adding a -2 each time. So our common difference is a -2. So if we write the recursive formula first, that means you're going to take your previous term, and then you're just telling me what you're doing to it. So you're taking your previous term, and we are subtracting 2. When you write a recursive formula, you do have to tell me what that first term was, where a sub 1 was 32. To write an explicit formula, we are going to have to use the equation a sub n is equal to a sub 1 plus n minus 1 times d. Now we do know our first term is 32, and we know our common difference is 2, -2. So we're going to take that -2 and we're going to distribute it. So a sub n is equal to 32 minus 2n plus 2. Or if we combine like terms, this will give us 34 minus 2n. So we have a recursive and an explicit formula. Find the 167th term of the arithmetic sequence. And we know the first 3 terms are -27, -8, and -11. So again, we're going to start by writing an explicit formula for this because I don't want to find all 167 terms. We know that our first term is -27. And we need to find the common difference. So what are you adding to get from -27 to -8? And that would be 19. And then -8 plus 19 gives us 11. So our common difference is 19. We're going to take that 19 and we are going to distribute it. So this is going to give us a sub n is equal to -27 plus 19n minus 19. Or our explicit formula is going to be 19n minus 46. Now we want to find the 167th term. So we're going to do 19 times 167 minus 46, and that tells us the 167th term should be 3,127. Find the indicated sum of the arithmetic series. So remember, when you're finding the sum of arithmetic series, we do have 2 different formulas you can use. You need to pick the one that you have the information for. On this case, we do not know what the last term is, So we will have to use the sum formula of n over 2 times 2 times a sub 1 plus n minus 1 times the common difference. So our common difference, to get from 120 to 114, we're adding a negative 6. And to get from 114 to 108, again, you would add a negative 6. So we do know that our common difference is negative 6. We are finding the 42nd term, so our n value is 42. And we do know that our a sub 1 is 120. So if we're finding the sum of our first 42 terms, we're going to do 42 divided by 2. And then it's going to be 2 times 120 plus n minus 1 times the common difference of negative 6. And if you put that all into your calculator, you will see that the sum of the first 42 terms should be 126. Find the specified term of the geometric sequence with the given characteristics. So we want to find the value of a sub 6. First, we're going to find our common ratio. So we can do the second term minus the first term. And this is going to give us a common ratio of 1/6. Now, our explicit formula for a geometric sequence is a sub n is equal to a sub 1 times r raised to the n minus 1 power. We know that our first term is 540, and we're going to multiply that by our common ratio raised to the n minus 1 power. Since we need to find the sixth term, we're going to raise this to the 6 minus 1 power, or we will see that our sixth term will be 0.0694. Find the indicated geometric means for the pair of non-consecutive terms. So we need to find two means. So this means we have the values 48, we have two values that we don't know, and then the next value we know is 750. Now this does tell me it is geometric, so that tells me which equation we should use. We know that our a sub 1 is 48. We know that our a sub 4 is negative 750. And we know that our n value is 4. Now, we have our equation. So our a to the nth term is negative 750. We know our first term is 48. We do not know what the r value is, but we do know we're raising it to the 4 minus 3 power. We can divide both sides by 48 to start. And this is going to give us negative 15.625 is equal to r raised to the third power, because 4 minus 1 gives us 3. To get the r by itself, we will take the third root of both sides, and that will leave us with r is equal to negative 2.5. So to find our other terms, we're just going to multiply by a negative 2.5. So if we do 48 times a negative 2.5, that's going to give us a negative 120. Negative 120 times negative 2.5 will give us 300. And to make sure we did this correctly, 300 times a negative 2.5 will give us a negative 750. Find the sum of the first 9 terms of the geometric series. So again, we're going to find that common ratio first. So negative 1 divided by 0.5 is going to give us a negative 2 as our common ratio. To find the sum, we're going to do a sub n times 1 minus r to the n power over 1 minus r. So we want to find the sum of the first 9 terms. Our first term is 0.5. We're going to do 1 minus negative 2 raised to the 9th, all over 1 minus negative 2. And if you put that all into your calculator, you'll get the sum of the first 9 terms will be 85.5.